Welcome to these gentle, soothing stories for sleep. I am so glad you are here with me tonight. Whether you are settling into bed, unwinding from the currents of a long day, or simply seeking a quiet harbor for your thoughts, you have found a safe place to rest. Tonight, we will embark on a journey together, a thought experiment of immense and profound scale, as we ask a simple, yet world-altering question. Before we begin, I would love to know where in the world you are listening from, or perhaps just a word about how your day has been. Please feel free to leave a gentle comment below. Wherever you are, I hope you are feeling comfortable, peaceful, and ready to explore something extraordinary. And if you find this journey into the quiet corners of science to be a welcome companion, please consider liking this video and subscribing to the channel. It helps other souls who are searching for calm find their way here to this shared space of wonder. Imagine, if you will, that we are standing together on a cliffside, a place you have perhaps known your whole life for the sound of crashing waves and the endless expanse of blue. But tonight, the sound is gone. The blue is gone. We are watching the final sunset, and its magnificent colors of fire and rose are not reflecting on a shifting, living ocean, but on a vast and empty basin of wet, glistening sand that stretches all the way to a horizon that now seems impossibly far away. The world's oceans are disappearing, not in a geological blink of an eye, but in the span of a single day, as if a cosmic drain has been opened at the bottom of the world. The air is thick with the smell you only ever find at the lowest of tides, a primal scent of salt, of brine, and of the million to billion lives that have been suddenly exposed to a sky they were never meant to see. The only sound is a strange, hollow whisper of wind flowing over the newly revealed contours of the seabed, a sound that does not belong here, a sound of profound and utter emptiness. The familiar rhythm of the world, the deep, planetary heartbeat of the tides, has ceased. All is still. This silence is the first great change, and it is a silence that speaks to the scale of what has been lost. We often think of the oceans as a surface, a blue map between the continents, but their reality is one of unimaginable volume. Contained within their basins is approximately 1.35 billion cubic kilometers of water, a quantity so vast that if you were to spread it evenly over the entire surface of the Earth, it would form a layer over 2.5 kilometers deep. It is the cradle from which all known life sprang, the warm, saline womb that nurtured the first single-celled organisms, the place where the long, slow, and miraculous story of evolution began. But the ocean was not just a passive nursery. It is, and has always been, an active and vital organ of the living planet. We can think of the great ocean currents, a system known as the thermohaline circulation or the global conveyor belt, as the planet's circulatory system. Just as our own blood carries warmth and nutrients throughout our bodies, this immense, slow-moving current of water transports heat from the equator towards the poles and brings cold, nutrient-rich water from the depths back to the surface. It is a system that moderates our climate, that gives London its mild winters and California its cool sea breezes, a planetary engine that ensures no part of the world becomes too hot or too cold. Its disappearance means this fundamental regulation is gone, leaving the continents to face the raw, unfiltered energy of the sun alone. And beyond the physical, there is a loss that we would feel in the deepest parts of our consciousness. The great psychoanalyst Carl Jung spoke of a collective unconscious, a shared pool of symbols and archetypes that all of humanity inherits. Perhaps the most powerful of these is the ocean itself. It is the symbol of the great unknown, the abyss of the unconscious mind, the source of dreams, of monsters, and of profound discovery. It represents both the origin of life and the terrifying formless chaos that preceded it. To lose the ocean is to lose a fundamental part of our own psychological landscape, to erase a word from our innermost language. We would be left standing on the shore of a great and terrible emptiness, not just in the world, but inside ourselves. And so we stand on our cliffside in the gathering dark, feeling the first chill of a world without its thermal blanket, a world without its heart, a world without its soul. A new and alien earth is being born in the twilight. As the last sliver of the sun disappears below the impossible new horizon, we might think that the greatest changes are over, but in truth, they have only just begun. The first and most immediate consequence of this vanishing is not the silence, nor the exposed land, but a colossal transfer of energy that will now be unleashed into the sky above us. What happens to the sheer, unimaginable quantity of energy required to turn 1.35 billion cubic kilometers of liquid water into vapor? According to the laws of physics, energy cannot be created or destroyed, only transformed. And the energy that was holding all of those water molecules together in their liquid state, the energy that kept the oceans as oceans, has now been released into the atmosphere in a single, silent, and terrifying transaction. It doesn't simply vanish into the ether. It is absorbed by the air we breathe, and this absorption begins a chain reaction that will tear the sky apart. We feel it first as a sudden, oppressive warmth that has nothing to do with the fading sun. The air grows thick, heavy, and wet, like the inside of a steam room. A deep, pervasive humidity blankets everything, clinging to our skin, making each breath feel like we are breathing warm water. Looking up, the stars fail to appear. Instead, the sky begins to glow with a strange, hazy, pearlescent light, the scattered luminescence of an atmosphere that is now saturated, supercharged with trillions upon trillions of tons of water vapor. We are standing at the bottom of a planetary-scale pressure cooker that is slowly being brought to temperature. To understand the power that has been unleashed, we must consider a concept from physics known as the latent heat of vaporization. This is the enormous amount of energy a substance must absorb to change its state from a liquid to a gas without changing its temperature. For water, this value is exceptionally high, around 2,260 kilojoules for every kilogram. To turn our planet's oceans into vapor would require a quantity of energy that dwarfs human comprehension, an energy input equivalent to detonating hundreds of billions of the largest nuclear weapons ever created, all at once. This colossal energy load does not just warm the atmosphere, it supercharges it into a state of unimaginable violence. Weather patterns as we know them would cease to exist, replaced by something far more terrifying. Scientists have theorized about storms called hypercanes, meteorological events so powerful they can only form when ocean temperatures reach extreme levels. But this is something else entirely. We would witness the birth of storms larger than continents, spinning with such ferocious velocity that their outer winds would break the sound barrier, creating a constant, planet-enveloping sonic boom. The sky would become a churning, chaotic engine of destruction. And as these storms rage, another, more insidious process would be taking place. Water vapor is the single most potent greenhouse gas in our atmosphere. While we often focus on carbon dioxide, a molecule of water vapor is far more efficient at trapping infrared radiation, the heat that radiates from the Earth's surface. With the entire volume of the oceans now suspended in the air, the planet's natural ability to cool itself by radiating heat into space would be almost completely shut down. The Earth would be wrapped in an invisible, insulating blanket of its own making. Temperatures on the surface would begin to rise catastrophically, not over centuries or decades, but over days and hours. A runaway greenhouse effect would take hold, pushing the global average temperature to levels that would make even the hottest deserts on our current Earth feel like a cool spring day. The very rocks beneath our feet would grow hot to the touch, and any remaining surface moisture on the continents would be baked away in an instant. The world would become a furnace, sterilized by the very water that once gave it life. We often think of water as a gentle, life-giving force, the soft rain, the lapping wave. But its departure reveals the true and terrible scale of its power, a power that was always held in perfect, delicate balance. In its liquid form, it moderated and cooled our world. In its gaseous form, it would incinerate it. But even as the sky burns with this new, humid fire, the planet itself will begin to respond to the great vanishing. Deep below us, beneath this tortured atmosphere, the very ground has started to stir, groaning and shifting under a colossal weight that has, in a single day, been lifted from its shoulders. We think of the ground beneath our feet as the very definition of solid, the foundation of our world, a symbol of stability and permanence. But this perception is a comforting illusion, born of our fleeting human timescale. On a geological level, the Earth's surface is a dynamic, shifting, and surprisingly fluid place. And for eons, much of this surface has been held in a delicate, pressurized balance by the immense, unimaginable weight of the sea. Now that the weight is gone, the planet's crust begins to stir. We would feel it not as a single, violent event, but as a constant, low-grade, pervasive tremor that runs through the soles of our feet, a deep hum that seems to emanate from the very core of the world. On the horizons, mountains that have been dormant for millennia, their volcanic hearts long thought extinguished, would begin to exhale, thin plumes of smoke and ash. The landscape itself, the newly exposed abyssal plains and the ancient continental shelves, would seem to be stretching, groaning, and sighing as it adjusts to a profound and sudden relief from an ancient pressure it has borne for millions of years. The solid ground is becoming restless. This phenomenon is known to geologists as isostatic rebound. The principle is surprisingly simple and can be understood with a gentle analogy. Imagine placing a heavy book on a soft cushion. The cushion compresses under the weight. Now, quickly lift the book away. The cushion doesn't just return to its original shape. It springs back, rebounding slightly higher before settling. The Earth's crust behaves in much the same way. It is not a solid shell, but a collection of tectonic plates floating on the semi-molten viscous layer beneath it, called the mantle. The sheer mass of the oceans, trillions upon trillions of tons of water, has been pressing down on the oceanic crust, depressing it into the mantle for geological ages. At the bottom of the Mariana Trench, for instance, the pressure exerted by the water column was nearly 2.75 times 10 to the 18th kilograms per square meter. When this weight is removed, the compressed seafloor and even the edges of the continents begins to rise. This is not a subtle shift. In places like Scandinavia, which was once covered by a massive ice sheet during the last ice age, the land is still rising by about a centimeter a year, thousands of years after the ice melted. With the far greater weight of the oceans gone, the seafloor could rebound by hundreds, or even thousands, of meters, creating new mountain ranges from what were once deep abyssal plains. This colossal adjustment of weight and balance would place an unbearable strain on the planet's already fragile fault lines. The great subduction zones, where one tectonic plate is forced beneath another, would be thrown into chaos. The Pacific Ring of Fire, a vast, horseshoe-shaped line of volcanoes and seismic activity, would awaken in a fury of eruptions and earthquakes of a magnitude we have never witnessed. Furthermore, the release of this immense pressure on the seafloor could trigger a phenomenon known as decompression, melting in the upper mantle. Just as opening a bottle of champagne causes the dissolved gas to bubble out, this release of pressure could cause vast quantities of rock in the mantle to melt into magma. This magma would surge upwards, leading to widespread submarine volcanism, venting stupendous volumes of gas and molten rock across the now dry seabed, creating new, black, volcanic plains under the superheated, hazy sky. The oceans, it turns out, were never just a passive feature on the Earth's surface. They were an active geological force, a calming, stabilizing hand on a restless and fiery planet. Their presence was a form of planetary peace, and as the new, warped landmasses continue to buckle and stretch, as new mountains rise and new volcanoes burn, another remnant of the vanished oceans would begin to take flight, a ghostly after-image of the sea, made of countless billions of shimmering deadly crystals. If you could taste the air in this new world, what would it taste of? Standing on the former coastline, a place that now borders a desert basin thousands of meters deep, the answer would be unmistakable. Salt. It would be a sharp, metallic, and incredibly dry taste that would coat your tongue and sting the back of your throat. For the ocean was never just water. It was a complex chemical soup, a solution of dissolved minerals washed from the continents over hundreds of millions of years. And now that the solvent, the water, has vanished into the sky, the solute, the salt, has been left behind. What was once the floor of the Pacific Ocean is now an endless, blindingly white plain of crystalline salt, the largest desert the world has ever known. Under the unfiltered glare of the sun, this vast salt pan would glint and shimmer, with fantastical crystalline structures eroded by the hot wind, rising like the towers of a ruined alien city. The silence here is absolute, broken only by the faint crackling sound of the salt crust expanding in the heat and the whisper of a rising wind. A wind that is about to become the world's newest and most terrible sculptor. The chemistry of seawater is what makes this new landscape possible. On average, every kilogram of ocean water contains about 35 grams of dissolved salts. While we primarily think of this as sodium chloride, or common table salt, it also includes salts of magnesium, calcium, and potassium, among others. When you multiply this concentration by the sheer volume of the oceans, you are left with a truly astronomical quantity of salt, an amount so vast it is difficult to express, enough to cover all of the Earth's landmasses in a layer of salt over 150 meters thick. Now, this immense deposit lies exposed, a fine, crystalline powder resting on the surface of the dry seabed. And as the hyperviolent storms born from the vaporized oceans begin to whip across the globe, they would lift these trillions of tons of salt particles into the atmosphere. This is the beginning of the salt storms. This is an example of what geologists call aeolian erosion, the process of wind shaping a landscape. But unlike sand, which is composed of relatively rounded, heavy grains of silica, salt crystals are often sharp-edged and much lighter. They can be lifted higher and carried further by the wind, creating perpetual, globe-spanning blizzards of abrasive salt. The consequences of these salt storms would be devastating and absolute. Anything left standing on the continents, the cities, the forests, the mountains themselves, would be relentlessly scoured by these salt-laden winds, a process of planetary-scale sandblasting that would erode them to dust over the coming centuries. The salt would also be deposited far inland, poisoning any soil that had not yet been baked into ceramic by the heat, rendering it sterile for millennia to come. The air itself would become thick with a saline haze, a fine white dust that would hang in the superheated atmosphere. This haze would scatter the sunlight in strange and unsettling ways, perhaps creating pale, mock suns in the sky, or causing the sunsets to glow with a sickly diffused pink light. The very colour of the sky would be altered by this ghost of the ocean. The salt that once gave the sea its life-sustaining buoyancy, the salt that is essential to the function of our own cells, the salt that is a memory of the land, would now become a sterile, abrasive, and suffocating blanket, smothering the world it once helped create. And as this new, dead world of salt and fire takes shape, we are forced to wonder about the fate of the creatures who knew nothing but the endless, life-giving blue. What was their final, silent chorus? Can you hear a sound that is no longer being made? In this new, silent world, scoured by salt and baked by a relentless, humid heat, the deepest and most profound silence of all would be the silence of the whales. Their songs, which once travelled for thousands of kilometres through the dense, conductive medium of water, have ceased forever. Their final notes were not a chorus of departure, but a scattered, confused, and desperate cacophony of calls into a world that was dissolving around them. Let us try, for a moment, to imagine the last moments from the perspective of the largest creature that has ever lived, the blue whale. It would have felt it first as a strange and growing pressure along its flanks, a sense of being squeezed by an invisible force. The water, its lifelong companion and supporter, the very substance of its world, would have felt as if it were becoming thin, insubstantial. The familiar, effortless buoyancy that had always cradled its 150-ton body would begin to fail, and for the first time in its life, the whale would feel the true, crushing reality of its own weight. Its desperate, powerful flukes would beat against a thinning liquid, finding less and less purchase, until finally it would come to rest on the soft mud of the continental shelf, beached not on a shore, but at the bottom of its own vanishing home. There, its own immense mass would become its executioner, compressing its internal organs, making it impossible for its colossal lungs to expand. Its last breath would be a final, shuddering exhalation into an alien atmosphere it was never meant to breathe. The fate of this last whale is the story of every creature in the sea, from the smallest krill to the greatest shark, multiplied by a number so large it borders on the infinite. We speak of extinction events in Earth's history, but what is happening on this day is something for which we have no name. It is the instantaneous and absolute annihilation of the largest biome on the planet. Over 90% of the habitable space on Earth is, or was, within the oceans. It is not just a habitat, it is a world of its own, with a diversity of life that far surpasses that of the land. Its disappearance means the end of entire phyla, whole branches from the tree of life, snipped away in a matter of hours. The intricate, beautiful, and sometimes terrifying ecosystems of the coral reefs, the mysterious and alien life of the abyssal plains, the vast teeming communities of the open ocean, all gone. Their end would be driven by a simple, brutal principle known as a trophic cascade. An ecosystem is not a collection of individual species, but a pyramid of energy transfer. At the very bottom of the oceanic pyramid is the phytoplankton, microscopic plants that capture the energy of the sun. These are eaten by zooplankton, which are eaten by small fish, which are eaten by larger fish, which are in turn eaten by apex predators like sharks and dolphins. With the ocean gone, the foundation of this pyramid, the phytoplankton, is instantly obliterated. And so, the entire structure collapses from the bottom up, a chain reaction of starvation that would race through the trophic levels with merciless speed. We spend so much time and energy looking to the stars, listening with our radio telescopes for any faint signal of intelligent life elsewhere in the universe. We dream of making contact with another mind, another consciousness. Yet, on this day, a world of profound, ancient, and subtle intelligence would vanish from our own planet without a proper witness to its passing. The complex social structures of dolphins, the navigational genius of sea turtles, the otherworldly consciousness of the octopus, the deep, resonant, and communicative culture of the great whales, all of it would be erased. It is a loss so complete and so profound that it is akin to losing a library containing the works of 1,000,000 unknown Shakespeares. It is the loss of stories, of songs, of ways of being that we, as land-dwelling primates, could never fully comprehend. Their final, collective breaths, the last metabolic act of trillions of dying organisms, would be a massive, planet-wide release of carbon dioxide into the already burdened atmosphere. It would be a tiny, final contribution to the dramatic and deadly shift in the air, a small gust of poison from the dying ocean that would serve as a warning to the life that still remained on land, as the planet itself, now deprived of its primary lung, slowly begins to suffocate. Take a deep breath. Feel the air fill your lungs, the gentle, unconscious miracle of oxygenation that powers every cell in your body, every thought in your mind. It is a rhythm so fundamental to our existence that we are not even aware of it. Now, imagine if every other breath you take, from this moment until the end of time, simply was not there. Imagine the feeling of a constant, nagging air, hunger, a sense that you can never quite get enough, that the world has become thin and unsatisfying. This is what the remaining life on Earth would begin to experience in the days and weeks following the Great Vanishing. It would not be a sudden, dramatic asphyxiation, but a slow, creeping, and global suffocation. We would feel it first as a pervasive listlessness, a constant headache that no amount of rest could cure. The simple act of walking would leave us breathless. Running would become a biological impossibility. Looking up, the deep, rich azure of the sky would seem to fade, replaced by a paler, greyer, and thinner blue, as if the very colour and substance of the atmosphere were being diluted. The planet is running out of air. The reason for this slow decline is the disappearance of the ocean's smallest inhabitants, the humble and often overlooked phytoplankton. These are microscopic, single-celled marine plants, like diatoms and coccolithophores, that float in the sunlit upper layers of the ocean. Though they are invisible to the naked eye, they are the most powerful and important life form on our planet. Through the process of photosynthesis, they take in carbon dioxide from the atmosphere, and using the energy of the sunlight, they convert it into organic matter for their own growth, releasing oxygen as a byproduct. It is a process identical to that of the trees and plants on land, but it occurs on a vastly greater scale. It is estimated that a specific type of phytoplankton, a cyanobacterium called Prochlorococcus, is alone responsible for producing up to 20% of the oxygen in our atmosphere. In total, all of the phytoplankton in all of the oceans are responsible for producing somewhere between 50 and 80% of the oxygen that we breathe. They are, in a very real sense, the planet's primary lung. With the oceans gone, this colossal oxygen factory has been shut down, instantly and permanently. Of course, the atmosphere contains a vast reserve of oxygen, a legacy built up over billions of years of photosynthetic activity. We would not run out overnight. But this reserve is now a finite resource, like money in a bank account with no more deposits being made. And there are still withdrawals. Every living creature that breathes, from the smallest insect to the last human, is constantly drawing down on this account. And there are other, non-biological processes of consumption as well. The slow oxidation of minerals in the Earth's crust, the process we know as rusting, is a chemical reaction that consumes oxygen, and the raging fires that would now be sweeping across the drying continents would consume oxygen at a ferocious rate. The complex chemistry of life is built upon the foundation of cellular respiration, the process by which our cells use oxygen to efficiently unlock the energy stored in the food we eat. As the concentration of oxygen in the atmosphere slowly drops, this fundamental process becomes less and less efficient. All aerobic life would enter a state of chronic metabolic decline. The ocean was not just the cradle of life where our distant ancestors were born. It has always been, and continues to be, the lung that sustains us with every breath we take. We have been living on borrowed time and on borrowed breath, and for the desperate, struggling life that remained on the parched and burning continents, this thinning air would be only one part of an increasingly hopeless search for the one substance that had now become the rarest and most precious commodity on the entire planet. What is the sound of a river dying? It is not a great and terrible roar, nor a final, gurgling gasp. It is a slow, fading whisper that speaks of a promise that can no longer be kept. Let us follow the path of one of the world's great arteries, a river like the Mississippi or the Amazon, in the first few months of this new, dry world. For a time, it would continue to flow, a ghost of its former self, fed by the last of the groundwater and the melting of the mountain snows. But no new rain comes to replenish it. The whisper begins. The once mighty current, which carried continents of silt to a sea that no longer exists, slows to a gentle meander. The broad, mile-wide expanse of water shrinks, pulling away from its ancient banks, leaving behind vast, sun-cracked flats of mud. Soon, it is no longer a river at all, but a chain of disconnected, stagnant pools, growing warmer and saltier by the day. And then, finally, even these disappear, leaving only a deep, winding scar on the landscape, a dusty, empty vessel that testifies to a time of impossible abundance. And as the rivers die, so too do the forests they once sustained. The great rainforests of the world, the planet's second lung, begin to wilt. The leaves of the canopy turn a sickly yellow, then a brittle brown, and fall to the forest floor, creating a carpet of tinder that awaits the first spark from the superheated air. The world is dying of thirst. This continental death is the inevitable and direct consequence of a broken promise, the severing of the most important cycle in our planet's entire system, the water cycle, or as it is known to scientists, the hydrologic cycle. We often think of the water on land, the rivers, the lakes, the rain, the ice, as a permanent feature of our world. But in truth, it is all just a temporary loan from the one great reservoir that is the ocean. The entire system is driven by the energy of the sun. Sunlight warms the surface of the ocean, causing water to evaporate, rising into the atmosphere as vapor. This moist air is then carried over the continents by the winds, where it cools, condenses into clouds, and falls as precipitation, as rain or snow. This water then flows into streams and rivers, replenishes the groundwater, is taken up by plants, or is frozen in glaciers. But eventually, inevitably, it all finds its way back to the ocean, where the cycle begins again. It is a closed, perfect, and perpetual system of renewal. But we have removed its engine. With no ocean to evaporate from, the creation of clouds and rain ceases completely and forever. There will be no new water. The existing supply is now all there is, and it is quickly vanishing. Even the plants themselves were participants in a smaller, secondary water cycle. A large tree, through a process called transpiration, can pull hundreds of gallons of water from the ground through its roots and release it into the atmosphere through tiny pores in its leaves. The great forests of the world acted as immense humidifiers, creating their own local rainfall and weather patterns. But as the groundwater table drops and the soil turns to dust, this biological pump begins to fail. The trees can no longer draw up the water they need to survive, and their contribution to the atmospheric moisture ceases. The continents are now hemorrhaging their last reserves of water into an atmosphere that is too hot and too chaotic to ever give it back. A process of desertification, already familiar to us in certain parts of the world, now goes global, spreading with a speed and finality that is terrifying to behold. We often speak of Mother Nature as a comforting, terrestrial concept, but we are now learning the deeper truth. The ocean was the true mother, the great universal provider, feeding the thirsty continents with an umbilical cord of rain. Now, that cord has been cut, and her children on the land are left alone in a silent, barren nursery. Yet, even as all life on the surface is extinguished by this relentless thirst, could there be a refuge? In the deepest, darkest, and most hostile parts of the vanished sea, in places that never knew the sun or the rain, could a different, more ancient form of life cling on? In a world scoured by salt, starved of breathable air, and baked by a runaway sun, could life's last bastion be a place that never depended on any of them? Could the final spark of Earth's biology be hiding in a place that has always been alien to us? A realm of crushing pressure and absolute darkness. Let us journey down, far down, into what was once the deepest part of the ocean, the Mariana Trench. It is no longer a trench, but a vast, dry canyon, the deepest canyon in the known solar system. The air here, more than 11 kilometers below the former sea level, is thick, dense, and suffocatingly hot, smelling strongly of sulfur and boiled minerals. The walls of the canyon are made of strange, dark rock, warped by pressures we can barely comprehend. And here, in the deepest part of this chasm, we find something miraculous. Strange, chimney-like structures of rock, some as tall as skyscrapers, rise from the canyon floor. They are black and grey and ochre, and from their tops a dark, shimmering haze emanates. It is superheated water, rich with dissolved minerals, venting directly from the Earth's mantle. And clustered around the base of these chimneys, life not only survives, it thrives. This is a world of extremophiles, organisms built to withstand conditions that would annihilate any surface life. The secret to their survival is a process that is as profound and as fundamental as photosynthesis, but which follows a completely different path. It is called chemosynthesis. Life at the surface is solar-powered. Plants capture energy from sunlight, but here, in the eternal darkness of the abyss, life is geothermally powered. The entire ecosystem is based on bacteria that have evolved to derive their energy not from light, but from chemical reactions. The hot water spewing from these hydrothermal vents is rich in compounds like hydrogen sulfide, the same chemical that gives rotten eggs their distinctive smell. To us, it is a poison. To these bacteria, it is food. They oxidize the hydrogen sulfide, and in doing so, they capture the chemical energy released in the reaction, using it to build their bodies and power their metabolism. They are the producers in this dark food web, the equivalent of the phytoplankton in the sunlit world above. And upon these bacteria, a whole ecosystem is built. Strange, giant tube worms with blood-red plumes, pale, blind crabs that scuttle over the rocks, and ghostly white fish that navigate by touch and pressure. This entire ecosystem is, and always has been, almost completely independent of the surface world. It does not need the sun. It does not need oxygen. It does not need the complex web of life that has now been extinguished thousands of meters above it. Its primary requirements are geothermal energy from the planet's core to drive the vents, and the presence of water, even if it is just the superheated fluid seeping from the rock. As long as the Earth remains geologically active, and as long as some water remains trapped deep within the planet's crust, These oases of life could potentially survive the apocalypse on the surface, islands of biology in a dead, dry world. Furthermore, these vents are just the most visible example of a much larger, unseen biosphere. Scientists now know that life exists deep within the Earth's crust itself, a deep biosphere of microbes that may account for a significant fraction of the planet's total biomass. This life, miles beneath the surface, would be entirely unaffected by the disappearance of the oceans. Life, it seems, is not just a delicate film on the surface of our planet. It has woven itself into the very fabric of the geology, a deep hidden reservoir of ancient and incredible resilience. But for the most complex life form of all, humanity, survival, would not depend on such elegant chemical adaptation. It would depend on a conscious, desperate, and terrible choice. A great migration. But before the body can move, the mind must first contend with a loss so total it threatens to break the very spirit of our species. How do you mourn something so large that you don't even have a word for its loss? We have words for the grief we feel when we lose a person, a home, or a dream. But there is no word in any language for the sorrow of losing an ocean, for the collective bereavement of an entire planet. In the aftermath of the Great Vanishing, this is the silent, psychological cataclysm that would befall the human spirit. Imagine standing on what was once a sandy beach, a place of joy, of holidays, of contemplation. The familiar, comforting line of the horizon, the meeting place of sea and sky, is gone. In its place is a dusty, brown, and alien vista, a seemingly infinite basin of salt and cracked mud that stretches down and away into a hazy, shimmering distance. All the poetry ever written about the waves, all the songs ever sung about the tide, all the myths of sea gods and ancient, drowned kingdoms, they would all become instantly incomprehensible, relics of a world that now feels like a fantasy. We would become a species that is profoundly, cosmically landlocked, trapped on a single, continuous, and monotonous landmass. The feeling of being able to set sail and cross a vast, mysterious expanse, the very concept of an island, the simple and profound pleasure of swimming in the sea, all of it would be relegated to the realm of history, as distant and unbelievable as a fable about dragons. There is a relatively new term in psychology, coined by the philosopher Glenn Albrecht, called solastalgia. It is meant to describe the specific kind of emotional or existential distress caused by negative environmental change. It is the homesickness you feel when you are still at home, but your home has been irrevocably altered. It is the grief of a farmer whose fields have turned to dust, or the anxiety of an indigenous community watching their ancestral forest being cleared. What humanity would be experiencing now would be the most extreme and all-encompassing form of solastalgia imaginable. Our entire home, the very face of our planet, has been changed into something unrecognizable and hostile. The biologist E.O. Wilson proposed what he called the biophilia hypothesis, the idea that humans possess an innate, genetically determined tendency to connect with nature and other forms of life. He argued that this connection is essential for our mental and spiritual well-being. If this is true, then the loss of the ocean, the cradle of all life, would inflict a deep and permanent psychic wound on every human being. It would be a fundamental disconnection from the source of our own being, a spiritual amputation. This profound loss would even begin to dismantle our language, the very tool we use to think and communicate. Consider how deeply the ocean is woven into the fabric of our metaphors. We speak of a sea of troubles, of drowning in sorrow, of being all at sea when we are confused. We encourage people to go with the flow, and we feel hope when the tide is turning. These are not just figures of speech, they are deep intuitive ways of understanding our own emotional and psychological states, using the powerful, universal symbolism of the water. In a world without oceans, these phrases would slowly be emptied of their meaning. Future generations, born into a dry and dusty world, would read them in ancient texts and struggle to grasp their visceral power. They would become historical artifacts, linguistic fossils from a lost world. In the end, we would realize that we had not just lost a physical feature of our planet. We had lost a part of our own minds. We had lost the great, universal symbol for the unknown, for the subconscious, for infinity, for both the terrible power of nature and its capacity for serene beauty. And with our spirits broken by this silent, internal grief, our bodies would be forced into motion. A last, desperate act of survival, a great and terrible pilgrimage toward the only reservoirs of frozen water that still remained at the cold, forgotten ends of the earth. When the entire world is a desert, a single ice cube becomes an oasis. A glacier becomes a god. In the empty, silent cities of the former temperate zones, this new reality would dawn with a terrible clarity. There is no more water here. The rivers are dead, the rain will never fall again, and the very air is becoming thin and unbreathable. The only hope for survival, the only source of the molecule upon which all life depends, is frozen and locked away in the great ice sheets at the poles. And so begins the last great adventure of humanity, the Great Migration. It would not be an organized, stately procession, but a desperate, chaotic, and silent exodus. Imagine vast, straggling caravans of people, and the last of their domesticated animals, moving slowly across the baked and shattered landscapes. They would leave behind the magnificent, useless cities of glass and steel, monuments to a civilization built on an assumption of endless water. Their journey would take them down from the continental shelves and across the newly exposed seabeds, landscapes of incredible danger and wonder. They would cross the dry, salty abyss of the Atlantic, navigating by the stars in a cloudless sky, passing the colossal, newly revealed mountain range of the mid-Atlantic ridge. They would find shelter in the hulls of perfectly preserved shipwrecks, their wooden timbers now petrified and ancient. Their destination, for those in the northern hemisphere, would be the great ice sheet of Greenland. For those in the south, the truly colossal ice sheet of Antarctica, the single largest reservoir of fresh water left on the planet. The Antarctic ice sheet alone holds approximately 61% of all the fresh water on Earth, a quantity so vast it is almost impossible to imagine. This frozen water, once a remote curiosity for scientists and explorers, would now become the most valuable and fiercely contested resource in existence, the foundation of a new, desperate, and fragile human civilization. But the journey itself would be a trial of almost unimaginable hardship, an event of selective pressure so intense it would reshape our species. There would be no fuel for vehicles, so the journey would be on foot. The temperatures in the deep, equatorial seabeds, now far below the former sea level where the air is thick and superheated, would be lethally hot. And in the higher altitudes of the continents, the thinning, oxygen-poor air would make every step a struggle. This would be a test of pure biological and psychological endurance. Those few who completed the journey would not find a paradise, but a frozen, wind-swept wilderness. Nations and ideologies would have dissolved during the long march, replaced by the more fundamental structures of the tribe or the clan. The new geopolitics of the world would be simple. You either lived close enough to a glacier to mine it for ice, or you perished. Humanity would reform itself into small, hardy colonies clustered around the edges of the great ice sheets, learning to carve out a life from the unrelenting cold and ice. All of civilization was born and nurtured on the warm, fertile shores of rivers and oceans. The next chapter of the human story, if there was to be one, would be a much colder and harder one, written on the unforgiving shores of ice. But what of the vast equatorial wastelands left behind? In those sterile, hypersaline basins, baked by a furious sun, in the shallow pools of brine that shimmer with strange colors, could some form of microscopic life, forgotten in the Great Migration, not only manage to survive, but actually begin to thrive? Where we, with our water-based biology and our deep memory of a blue world, see only a sterile and hostile wasteland, life itself sees a new and challenging home, a frontier waiting to be conquered not by strength, but by profound biochemical ingenuity. Let us leave the desperate human survivors in their icy polar refuges and travel back to the equator, to the vast, shimmering salt flats that were once the Mediterranean Sea. From a distance, this basin appears to be a uniform, blinding white, a place utterly devoid of life. But as we draw closer, we see that it is not white at all. The great salt pan is streaked and stained with impossible colors, with vast patches of pastel pink, blood red, and even vibrant orange. We approach one of the few areas where a tiny amount of liquid remains, a shallow, shoreline pool of super-concentrated brine, a solution so saturated with salt that it is thicker and more viscous than syrup. And we see that this strange, oily liquid is teeming with microscopic life, the source of the incredible colors that paint this Dead Sea. The water is gone, but life, in some strange and stubborn form, remains. The organisms that thrive in these extreme conditions are known as halophiles, a name that comes from the Greek for salt-loving. For most forms of life, an environment this salty would mean instant death. The reason for this lies in the fundamental process of osmosis, the tendency of water to move across a semi-permeable membrane, like a cell wall, from an area of low solute concentration to an area of high solute concentration. In simpler terms, if you place a normal cell in a brine solution, the water from inside the cell is violently drawn out into the saltier environment, leaving the cell dehydrated and shrunken, a process called plasmolysis. But the halophiles have learned to cheat osmosis. They have evolved one of two remarkable strategies to survive. Some of them, the salt-in strategists, actively pump salt from the outside environment into their own cells, matching the external salinity and thus preventing water loss. The other, more common strategy is to produce or accumulate massive amounts of benign, organic solutes inside their cells, substances like glycerol or specific amino acids. This raises their internal concentration to match the outside world, creating a perfect osmotic balance. They have learned not to fight the salt, but to become like it. The spectacular colors we are witnessing in these brine pools are themselves a form of adaptation. One of the most successful inhabitants of this new world would be a type of microalgae called Dunaliella salina. It is one of the primary sources of the pink and red hues. In order to protect itself from the incredibly intense solar radiation of the cloudless sky, which is amplified as it reflects off the white salt flats, this algae produces enormous quantities of beta-carotene, the same pigment that gives carrots and flamingos their color. It is a form of planetary-scale sunscreen, so the strange, beautiful, and alien colors of this new landscape are not a sign of death, but a testament to the quiet, microscopic, and desperate struggle for survival. Life's true genius is not demonstrated by its ability to thrive in the lush, ideal conditions of a rainforest or a coral reef. Its deepest and most profound ingenuity is revealed in its capacity to rewrite its own fundamental rules, to alter its very chemistry in order to inhabit the impossible. This strange, colorful, and microscopic new form of life would be just one of the many secrets that the retreating waters decided to reveal. A new beginning that exists right alongside the silent, long-forgotten ghosts of our own past. The ocean floor has always been the greatest museum on the planet, a silent repository holding the secrets of geology and the entire history of our species. But its doors were always sealed, locked away from us by 5 kilometers of crushing, dark water. Now, in this dry and desolate world, those doors have been thrown open. To walk the floor of what was once the Atlantic Ocean would be an experience of profound and unsettling awe, a journey through a truly alien landscape that was never meant for human eyes. As we walk east from the ruins of New York, we descend the gentle slope of the continental shelf and emerge onto the abyssal plain, a vast, flat expanse of hardened mud, smoother and more featureless than any landscape on the continents. In the distance, a sight of impossible scale begins to rise. It is the Mid-Atlantic Ridge, a colossal, undersea mountain range that runs the entire length of the globe, a geological seam where new crust is born. Its highest peaks, which were once volcanic islands like Iceland and the Azores, are now the tallest mountains on the planet, their summits reaching into the thin, cold, oxygen-starved upper atmosphere. The sheer, raw geology of the planet is laid bare, and scattered across this alien terrain are the relics of our own history, preserved with an eerie and perfect stillness. We would find the wrecks of ships from every era of human seafaring. A Roman galley, its amphorae still neatly stacked in the hold. A Viking longship, its dragon prow pointing towards a land it never reached. The great Spanish galleons, their hulls breached not by cannons or storms, but by the slow, gentle settlement onto the seabed, their treasures now lying in the open, dulled by a thin layer of ancient dust. We would find the ironclad battleships of the world wars, silent and imposing, and the sleek teardrop hulls of nuclear submarines, technological marvels that now seem like pointless, archaic toys. The reasons for their remarkable preservation lie in the unique chemistry of the deep ocean. The extreme cold, the lack of oxygen, and the immense pressure all work together to dramatically slow the processes of decay. Wood does not rot, and iron corrodes at a glacial pace. In our grief, we would become the first archaeologists of our own drowned world, piecing together the story of our long, complicated relationship with the sea from the ghosts it had chosen to keep. Beyond our own history, we would discover natural wonders that would dwarf anything we had ever known on land. The submarine canyons, like the Hudson Canyon off the coast of New York, would be revealed to be chasms far deeper and more dramatic than the Grand Canyon. We would stand on the edge of the continental slope, a cliff that in some places drops for thousands of meters in a sheer, unbroken wall. We would walk among the forests of seamounts, extinct volcanoes that rise for kilometers from the abyssal plain, their flanks carved and shaped by deep ocean currents whose power we can only now appreciate by the evidence they left behind. It is a landscape sculpted not by the familiar forces of rain and wind, but by pressure, by upwellings, and by the slow, patient gravity of water itself. It is a world that tells a story of a different set of physical laws, a different kind of time. And as we stand in the bottom of one of these newfound, colossal canyons, looking up at the strange, hazy, cloudless sky, we would begin to notice a subtle but profound change in the light, a change that signals that our planet's very face, as seen from the heavens, has been transformed. We called it the blue marble. From the moment the first human eyes saw our home from the blackness of space, that is what it has been for us. A startlingly beautiful, delicate, and living sphere of swirling white clouds, brown continents, and deep, profound blue. It was a name that spoke of life, of uniqueness, of a precious and watery miracle in the vast, empty, dark. But what would we call it now? If we could float in that same orbit, in that same privileged position above our world, the sight that would greet us would be one of heartbreak and desolation. The blue is gone. All of it. In its place is a dull, uniform, and lifeless ball of ochre, tan, and glaring white. The familiar, comforting shapes of the continents are now indistinct, their sharp coastlines completely erased and blurred into the vast, pale salt flats that have replaced the oceans. The polar ice caps, the last refuge of our species, gleam with a desperate, lonely brightness against the muted tones of the rest of the planet. It no longer looks like a marble of blue and white, but more like a scarred and dusty ball of clay. It looks more like Mars than the Earth we knew. It looks like a world that has died. This dramatic change in appearance is the result of a fundamental shift in the way our planet interacts with the light of the sun, a concept known in physics as albedo. Albedo is simply the measure of how much light a particular surface reflects. A surface with a high albedo, like fresh snow, reflects most of the light that hits it and appears bright. A surface with a low albedo, like dark, deep water or thick forest, absorbs most of the light and appears dark. The deep blue oceans were vast, dark surfaces that were incredibly efficient at absorbing solar radiation, trapping the sun's energy, and using it to warm the planet and drive the weather. Now, these dark, absorbent surfaces have been replaced by the largest, brightest surfaces imaginable. Continent-sized fields of brilliant white salt. This new, high albedo surface would reflect a much greater percentage of the incoming sunlight straight back into space. The initial effect of this, after the initial superheating from the atmospheric water vapor had subsided, would be a powerful and sustained global cooling, plunging the world into a permanent ice age. The loss of the blue color itself is a change that strikes at the very identity of our world. The reason the oceans appeared blue from space was twofold. Primarily, it was a reflection of the blue sky above them. That blue sky is a result of a phenomenon called Rayleigh scattering, where the molecules in the atmosphere, mostly nitrogen and oxygen, are more effective at scattering the shorter, blue wavelengths of light than the longer, red wavelengths. This is why the sky is blue and sunsets are red. The ocean, being a reflective surface, simply mirrored this color back to space. Water itself also has a slight intrinsic blue color, due to the way its molecules absorb light at the red end of the spectrum, but this is a much smaller effect. On our dry Earth, Rayleigh scattering would still occur in the thin, cloudless atmosphere, so the sky would still appear blue to an observer on the ground. But from space, this thin blue haze would be completely overwhelmed by the light reflecting off the planet's new, pale brown and white surface. From a great distance, the life on our planet was always invisible. But the potential for life, the very thing that made our world special, was broadcast across the solar system by that brilliant, unmistakable blue. Now, from a distance, our world would look like just another dead and silent rock in the void. And yet, even on this pale brown dot, the memory and the essence of the ocean would remain, not just in the shimmering salt flats that scar its surface, but in the very blood flowing through the veins of its last, struggling survivors. You can never lose the ocean completely, because you are, in a very real and biological sense, a small, walking, thinking piece of it. In the final, desperate struggle for survival at the frozen poles of a dry world, this truth would become both a source of profound connection and a terrible, constant burden. Let us turn our attention away from the vast, cosmic perspective and focus on the most intimate and personal of sensations. The feeling of a single tear rolling down your cheek in a moment of grief or memory. The automatic, unconscious act of putting that tear to your lips and tasting, with a shock of recognition, the unmistakable flavor of salt. The feeling of your own blood, warm and rhythmic, pulsing through your body. The deep, instinctual awareness that you are made, fundamentally, of water. That every cell, every muscle, and every single thought flickering through the neurons in your brain is bathed in and dependent upon this precious, internal fluid. This is the ocean that can never be taken away from you, the ocean that you carry within. This is not a poetic metaphor. It is a literal, biological fact. The composition of human blood plasma, the fluid matrix that carries our blood cells, has a remarkably and eerily similar salinity and ionic concentration to that of seawater. The delicate, microscopic environment in which every one of our trillions of cells lives and breathes is, in essence, a tiny, perfectly maintained internal sea. This is one of the most powerful and beautiful pieces of evidence for our own evolutionary history. Life on this planet began in the ancient oceans, and for billions of years, the single-celled organisms that were our ancestors existed in a state of simple equilibrium with the saline water around them. But when the first vertebrate creatures crawled out of the water and onto the hostile dry land, they faced a fundamental biological crisis: how to keep their cells from drying out. The solution that evolution arrived at was as simple as it was brilliant. They took the ocean with them. They evolved skin, an impermeable barrier, and in doing so, they enclosed a small sample of their ancestral, oceanic home inside their own bodies. A portable, perfectly regulated environment that allowed their cells to function just as they always had. Our tears, our sweat, and our blood are all echoes of that primordial sea. We are living arcs. This deep, ancestral dependence is absolute and unforgiving. On a world where liquid water has become the rarest substance imaginable, the constant, desperate struggle to maintain this internal ocean would define every moment of existence. A human being can survive for weeks without food, but only a few days without water. A loss of just 1 or 2% of your body's water leads to thirst and impaired cognitive function. A loss of 10% leads to catastrophic systemic failure. The survivors at the poles, mining the ancient ice of the glaciers, would understand this truth with a clarity we can barely imagine. We think of survival as an external quest, a search for shelter, for food, for resources in the world around us. But on a deeper level, it is a constant, desperate, and internal struggle to maintain the ancient, watery legacy that we all carry within our very veins. It is a fight to keep the ocean inside of us from running dry. And if our very biology is a living memory of water, what would the sky of this new Earth, a sky now stripped of its oceanic connection, remember? What would a world without the gentle, shifting poetry of clouds even look like? Have you ever looked up at a perfectly clear, deep blue sky and felt a strange and subtle sense of emptiness? A feeling that the world is too bright, too exposed, too simple. Now, imagine that feeling amplified 1,000 times, and imagine it lasting forever. This is the new reality of the sky in a world without oceans. The daily experience of light and darkness on this dry earth would be one of brutal, stark, and unforgiving clarity. The sun would not rise with a gentle diffusion of light, its arrival heralded by soft pastel colors of dawn. It would simply appear, a sharp-edged, blinding disk that flicks on like a switch, casting shadows that are unnaturally dark and well-defined. There would be no softness to the world, no shade, no gentle haze to obscure the horizon. The heat of the sun would be direct and searing, a raw and unfiltered radiation that beats down from a sky that is a single, monotonous, and piercing shade of blue. And at night, the transition would be just as abrupt. The sun would set, and the world would be plunged into an immediate, profound darkness. This night sky, without a trace of atmospheric moisture to blur the view, would be a terrifyingly clear and beautiful sight. The stars would not twinkle. They would shine with a hard, steady, and unwavering light, like tiny holes drilled into a black velvet dome. The Milky Way would stretch across the sky, not as a gentle, milky cloud, but as a vast, granular river of light, so clear and so dense that it would feel close enough to touch. This dramatic and permanent change in the sky is due to the complete absence of clouds. We often think of clouds as mere features of the weather, as temporary carriers of rain, but they are, in fact, one of the most critical components of the entire planetary climate system, acting as both a shield and a blanket. During the day, their bright white tops have a very high albedo, reflecting a significant portion of incoming solar radiation back into space. This is why a cloudy day is cooler than a clear one. They are the planet's parasol, shielding the surface from the full intensity of the sun. At night, they play the opposite role. They act as an insulating blanket, trapping the heat that radiates from the surface of the Earth and preventing it from escaping into space. This is why a clear night is so much colder than a cloudy one. On our new, cloudless Earth, both of these crucial functions are gone. Without their protective shield during the day, the surface temperature would soar to extreme, scorching levels. And without their insulating blanket at night, all of that accumulated heat would radiate away instantly into the blackness of space, causing the temperature to plummet to far below freezing. This is a phenomenon we see in the deserts of our own world. But now it would happen on a global scale, a daily cycle of extreme heat and extreme cold that would make it almost impossible for any complex life to survive on the surface. And beyond the physical effects, there would be a deep psychological and aesthetic loss. The clouds were the Earth's poetry, its moods and emotions written in water vapor across the canvas of the sky. They were a source of infinite variety and beauty, from the delicate, feathery wisps of cirrus clouds to the towering, majestic thunderheads of a cumulonimbus. They gave us the comforting greyness of an overcast day and the spectacular, fiery beauty of a sunset. They were a canvas for our imaginations, a place where we could lie on our backs and see the shapes of dragons and faces and continents. A perpetually clear and empty sky would be a monotonous and oppressive dome. It would be a sky with only a single, stark, and unchanging expression. It would be the beautiful, but ultimately sterile and empty, sky of a dead world. And in this stark and unforgiving new world, under this clear and merciless sky, could life ever hope to begin again? Could a single seed, a spore that has lain dormant for millennia in the frozen, protected earth, find a way to spark a second, improbable genesis? Life on Earth has been nearly extinguished before. It has faced the crucible of planetary ice ages, the fury of supervolcanoes, and the deep, suffocating darkness of asteroid impacts. The Great Dying, at the end of the Permian period, wiped out over 90% of all marine species and 70% of terrestrial life. The Chicxulub impact which ended the reign of the dinosaurs, plunged the world into a nuclear winter. And yet, after each cataclysm, life returned. It clawed its way back from the brink, diversifying and filling the empty niches with new and wonderful forms. But does the blueprint for life, the fundamental spark of biological information, ever truly disappear? Or does it simply go into hiding, waiting patiently for the right moment to begin again? Let us imagine a place, perhaps deep within a subterranean cave system in what was once Siberia, a place that has been protected from the harsh radiation and extreme temperatures of the new surface world. Here, in the frozen soil of the permafrost, a single, precious drop of water, the result of a tiny geothermal anomaly, melts and seeps downwards, falling upon a single, microscopic bacterial spore that has lain dormant and frozen for 50,000 years. And within that spore, something stirs. A flicker of metabolic activity, a whisper of chemistry, the first spark of a new life in a dead world. The resilience of life at the microbial level is something that verges on the miraculous. We are fragile, water-dependent creatures of flesh and blood, but the world of microbes operates by a different set of rules. Bacteria have been found thriving in the cooling pools of nuclear reactors, in the boiling acid of volcanic springs, and in the hypersaline waters of buried Antarctic lakes. A bacterium known as Deinococcus radiodurans can withstand doses of radiation 1,000 times greater than what would kill a human, and can survive the cold, airless vacuum of space. Bacterial and fungal spores can enter a state of suspended animation, a deep and death-like dormancy, in which they can survive for millions of years, waiting for a single drop of water or a whisper of warmth to reawaken them. The seeds of some plants, like the Arctic lupine, have been found to be viable after being frozen for 10,000 years. The Earth, even in its dry and seemingly sterile state, would be seeded with these countless trillions of microscopic time capsules, a hidden library of biological potential. Scientists have even speculated about the existence of what they call a shadow biosphere, a realm of microbial life on Earth that is so biochemically different from our own that we have not yet even detected it. Perhaps it exists deep within the Earth's crust, utilizing different solvents or building its molecules in unfamiliar ways. Such a biosphere would be completely untouched by the surface apocalypse and could, over geological timescales, emerge to recolonize the planet. And there is an even stranger possibility. The theory of panspermia suggests that life on Earth may have originally been seeded by microbes, hitching a ride on comets or asteroids from elsewhere in the cosmos. In our new world, this process could happen in reverse. A large meteorite impact on the dry Earth could blast rocks containing these incredibly resilient spores into space. These spores could then travel through the solar system, perhaps one day landing on a more hospitable world, like Mars or the moons of Jupiter, and seeding that world with the legacy of earthly life. Our planet, in its death, could become the source of a new genesis elsewhere. Life may not survive in a form we would recognize, as humans, as animals, as forests, but the fundamental process of life itself, of information replicating, mutating, and adapting, might just be an unstoppable and universal force. But if that tiny, lonely spark in the Siberian cave were to fail, if all the dormant spores and hidden microbes were to eventually fade to nothing, then the planet would continue its long story, written not in the elegant code of DNA, but in the slow, brutal, and patient language of stone and wind. There is an old philosophical question. If a tree falls in a forest and no one is around to hear it, does it make a sound? We could now ask a similar question of our silent, empty world. If a planet exists with no life to witness it, is it still beautiful? Does it still have a story? The answer, written on a timescale that dwarfs our own, is a profound and resounding yes. Let us step away from the fleeting timescale of biology and watch this dry earth as it spins through the unblinking gaze of deep time. 1,000,000 years pass. 10 million. 100 million. The violent, superheated storms have long since subsided. The thin atmosphere is now cold and clear, and a new, patient, and relentless sculptor is at work, shaping the face of the planet. That sculptor is the wind. With no water to bind the soil, no plants to hold the sand, the winds now blow unimpeded across the single, globe-spanning desert. The great mountain ranges that were once revealed or created in the cataclysm of the vanishing, like the mighty mid-Atlantic ridge, are slowly but surely worn down, their hard volcanic rock scoured into vast, flat-topped mesas and strange, wind-carved arches. The endless salt flats are lifted and transported, grain by crystalline grain, and deposited elsewhere, creating flowing, shimmering dune seas the size of continents, vast oceans of sand and salt that move in slow, silent waves across the planet's surface. The familiar outlines of the continents, the very shapes that defined our maps and our world, are slowly, patiently, and irrevocably erased. On this dry and wind-swept world, the fundamental geological force shaping the landscape has shifted. For billions of years, Earth's story was written by water. It was a world of fluvial erosion, where rivers carved canyons, glaciers ground down mountains, and waves shaped coastlines. Now, it has become a world of purely aeolian erosion, shaped by the wind alone. Its new landscapes would come to resemble those of Mars, a planet that lost its own oceans billions of years ago. There would be vast plains of dark volcanic sand, immense fields of crescent-shaped Barchan dunes, and deep, wind-scoured canyons. But beneath the surface, the heart of the planet would still beat. Plate tectonics, the slow, ponderous dance of the continents, would continue, driven by the heat of the Earth's core. Continents would still drift, colliding to form new supercontinents over hundreds of millions of years. New mountains would still rise, buckling and folding upwards. But as soon as their peaks reached into the thin, abrasive air, they would be relentlessly attacked and worn down by the eternal, salt-laden winds. The very nature of the rocks themselves, the planet's memory, would change. The rock cycle would be fundamentally and permanently altered. Sedimentary rocks, which make up so much of our current geological record, are most often born in water. Limestone is formed from the shells of marine organisms, shale from deep-sea mud, and much sandstone from ancient river deltas and beaches. In this new world, these rocks would no longer be created. The new sedimentary rocks would be vast, cross-bedded layers of wind-deposited sandstone and thick, crystalline beds of evaporites, the salt deposits left behind from the final drying. The planet does not need life to have a story. Its autobiography is written in its strata, a slow, majestic, and utterly inhuman narrative of pressure, heat, erosion, and time. And if, in the vastly distant future, after 1 billion years of this slow aeolian poetry, another intelligence from another star were to visit our silent, sculpted world, what story would they read in that ancient, rocky book? We define the value of a thing by its rarity. Gold is precious because it is scarce. A diamond is treasured because it is hard to find. In a world without oceans, in a world where every last drop of surface water has been boiled away into the unforgiving vacuum of space, what becomes the new gold? The answer is simple and absolute. Water itself. Let us travel forward in time to a small, flickering campfire in a deep, ice-carved valley on the coast of what was once Antarctica. Here, huddled in furs made from the skins of the last hardy animals, are the distant descendants of humanity. They are a people for whom our world of blue is a distant, half-believed myth. They tell stories passed down through 1,000 generations, not of gods and heroes, but of a magical substance called rain that used to fall from the sky. They whisper legends of vast, shimmering pools of water so large you could not see the other side. To these people, a single, hand-carved cup filled with pure, clear, liquid water, melted from the ancient ice of the glacier that is their home and their god, is the most sacred of relics. It is a symbol of life, of wealth, of power, a treasure more valuable than all the diamonds and all the gold that lie useless and forgotten in the ruins of the old world. The survivors of the Great Vanishing would have undergone a profound philosophical and psychological transformation, a complete paradigm shift from a worldview of abundance to one of absolute and terrifying scarcity. Our entire civilization, our ethics, our economics, our social and political structures, were all built upon the unspoken assumption that water would always be available. It was the one constant, the one resource we believed to be practically infinite. Its absence would force our descendants to build a new society, a new morality, based on its conservation. Every action would be weighed against its cost in water. To waste a single drop would be the greatest of all possible crimes. Our art, our music, and our culture would all revolve around the memory and the worship of water. Artists would try to recreate the mythical color blue from crushed minerals, a color no one has seen in its true oceanic form for generations. Singers would try to imitate the sound of waves, a sound described only in the most ancient of texts. Water would cease to be a chemical compound and would become a religious concept, a divine substance to be prayed to, celebrated, and feared. And perhaps, over the long, hard millennia, the very meaning of the word life itself would begin to change. Biological life, as we know it, is simply too thirsty, too fragile, too dependent on this impossibly rare substance. In the cold, clear, and logical minds of these survivors, it might come to be seen as a flawed and inefficient design. Perhaps they would turn their intelligence towards escaping the tyranny of biology altogether. They might dream of a new form of existence, of uploading their consciousness into resilient, crystalline machines that do not need to drink, that do not weep, that do not bleed. They might see the future of humanity not in flesh and blood, but in wires and silicon. A transhumanist dream born of absolute necessity. A world without water might, in the end, decide that it can no longer afford the luxury of biological life. We only ever truly understand what something is in the moment we realize it is gone forever. The great and terrible absence of the ocean would finally teach the last of our species what it truly meant. It meant everything. And this memory, this desperate and sacred story of water, would be the last echo of a living world. But even memories, especially memories held that dearly, can become fossilized in the rock of time. Every fossil tells a story. A single trilobite, frozen in stone, speaks of ancient, shallow seas and a world without flowers or forests. The delicate bones of an Archaeopteryx tell the tale of the moment when dinosaurs began to dream of flight. Every fossil is a word, a sentence, a chapter in the immense and patient biography of our planet. So what would be the final story of a world that died of thirst? What message would be left for an alien intelligence, 1 billion years from now, who might stumble upon our silent, rust-colored sphere? Let us imagine them, these patient and curious explorers from a distant star, landing their ship on the vast, wind-scoured plains of what was once the Pacific Basin. Their science is advanced beyond our imagining. They do not need to look for ruins. They can read the history of a world in its very rocks. They deploy a drill, which bores deep into the planetary crust, pulling up a long, cylindrical core of ancient, layered stone. And as they analyze this core, their sensors would detect something so strange, so abrupt, and so catastrophic that it would mystify them. They would have found the last, fossilized message of the blue planet. This message would be written in the language of stratigraphy, the science of reading the layers of rock that have been laid down over geological time. For billions of years, the story told by these layers would be one of a vibrant, watery world. The alien scientists would find thick, continuous bands of limestone, chalk, and shale, rocks that are born in water and are filled with the fossilized remains of trillions upon trillions of marine creatures. They would find the microscopic calcium carbonate shells of foraminifera, the delicate, glassy skeletons of diatoms, the fossilized bones of fish, and the faint impressions of soft-bodied creatures from the dawn of time. The rocks would sing with the evidence of a thriving, global ocean that had persisted for eons. And then, suddenly, it stops. The record would show a sharp, dramatic line etched into the geology of the entire planet, a boundary known as an unconformity. Below this line, there is a world of water teeming with life. And immediately above it, nothing. The layers of limestone and shale would be replaced by thick deposits of wind-blown sand and crystalline salt. The rich and diverse fossil record would be completely and utterly extinguished. The chemistry of the rocks would tell an even more dramatic story. By analyzing the isotopic ratios of certain elements, these future scientists could reconstruct the ancient atmosphere. They would see the clear chemical signature of a world with a dense, water-rich atmosphere that suddenly, in a geological instant, vanished. The rocks would scream of a catastrophic event, a planetary-scale desiccation so rapid and so total that it left no time for adaptation, no chance for escape. The final chapter of Earth's geological autobiography would be a mystery, a vibrant, life-giving ocean, present for nearly 4 billion years, gone in the blink of a geological eye. The Earth's final message to the cosmos, the last story it would ever tell, would be a stark and silent warning, written in the universal language of geology and chemistry. It would be a cautionary tale, a planetary epitaph that says, "Cherish your oceans. Cherish the miracle of your water. You are only a blue marble for a fleeting, precious moment in the great, dark expanse of time." But perhaps, even in this story of absolute and final loss, the ocean is not truly gone. Perhaps it has only changed its form, waiting in the endless night of the cosmos to be reborn, just as its faint echo still lives on inside of us. Throughout this long and quiet journey, we have been asking ourselves what would happen if the oceans ran dry. We have explored the consequences, from the fury of the burning sky to the deep, slow poetry of the wind-carved stone. But perhaps, as we come to the end of our story, we have been asking the wrong question. Perhaps the real question is not if the oceans could disappear, but can an ocean ever truly, fundamentally, disappear at all? Let us lift our gaze one last time, away from the dry and silent earth, and look up into the deep, clear, and star-filled night. We see the faint, ghostly glow of a nebula, a vast and beautiful cloud of interstellar gas and dust, where new stars and new planets are, at this very moment, being born. We see the silent, graceful streak of a comet, a dirty, cosmic snowball, making its long journey from the cold, outer darkness of the solar system. In these celestial sights, we are witnessing the beginning and the continuation of the ocean's story. The water that made our planet a living world was not born here. It is far older than the Earth itself. The hydrogen that forms its backbone is the most common element in the universe, forged in the first few minutes after the Big Bang. The oxygen, the other essential component, was created in the fiery hearts of ancient, long-dead stars. These two elements, hydrogen and oxygen, drifted through the emptiness of space, eventually combining to form water molecules in the cold, dense clouds between the stars. It was from these clouds that our solar system formed. And in its early, chaotic days, the young Earth was bombarded by comets and asteroids, icy visitors from the outer solar system that delivered the water, drop by precious drop, to our barren, rocky world. Our ocean was a gift from the cosmos, and the water that vanished from our hypothetical dry Earth would, in a sense, simply be returning home. In the upper atmosphere, the intense radiation from the sun would slowly break the water vapor molecules apart, a process called photodissociation. The oxygen would remain, but the hydrogen, being the lightest of all elements, would eventually escape the pull of Earth's gravity and drift back out into space, to one day become part of another nebula, another star, and perhaps another living, watery world. The ocean, then, is not really a static thing, a noun. It is a process. It is a verb. It is a great and ancient cycle of coming and going that operates not just on a planetary scale, but on a cosmic one. The ocean was a temporary visitor to our world, a visitor that stayed for 4 billion years, and, in its time here, gave us the greatest gift in the known universe. The gift of life, of thought, of consciousness. To lose it would not be an end, but a profound and painful transformation. We would be left as its children, its memory keepers, carrying its ancient, saline legacy in our blood and in our tears, and its scattered atoms would carry on, participating in the endless, beautiful, and silent dance of the universe. We are, and we always will be, children of the stardust and the water. Thank you so much for joining me on this long, gentle journey tonight. I hope it has given you a space for quiet contemplation and deep rest. Wherever you are in the world, I wish you a peaceful night and the sweetest of dreams. If you've enjoyed our time together, please do consider liking this video and subscribing for more soothing stories from the quiet corners of science. It truly helps our small community grow. Good night.